My name is Renalias. I'm a senior technology architect from Accenture. I've been here now for a number of years. I'm actually here in Finland, and you can tell by that I'm speaking English, so the extent of my domain of Finnish is very limited, so despite being here for some time. So that's me, that's where you can find me. Twitter, I need some followers. If anybody can follow me after today's talk. I'm also a big proponent of open source, both personally and finally with Accenture, we've been actually able to get our GitHub Opens repository up and running, so we're publishing some of our latest stuff in there, so that's for you guys to have a look, and the rest is where you can reach me. I'm actually here, I'm leading DevOps here in Finland. I'm also part of the global team pushing containers. I'm also part of the global team helping our clients define modern application architectures. And we'll see later, this is not a coincidence. All these topics are very much related, and today we'll see how we can get all those things together with a few secret ingredients on top to really get ourselves to, as the title of the presentation said, deploy 50 times a day. Is that something you're doing now? Does anybody here deploy 50 times a day? 50 times a week? A month? Right, so we definitely have to work on that. All right, so let's take a few steps back. Let's go back to 2009 when I think we can say that when the DevOps thing really started. So we had a company like Netflix coming out and saying, we're doing 10 deploys a day. That's not bad. Fast forward a few years, we have a company like Etsy saying, we're doing 50 deploys a day. It's a really good number. Last year, Amazon was saying we're deploying to production 11.6 times per second, or every 11.6 seconds, sorry. If you do the math, that's about 7,548 deployments per day, which is not bad at all. And the fact that none of you could say we're doing even 50 deploys a week or a month, it means we're quite far from that. And hopefully, during today's presentation, we can actually make some progress, get some food for thought to really achieve that goal. But why did these companies really go through the trouble of setting themselves up to achieve that? What is it? What's in there for Netflix, for Etsy, for Amazon to really do that, right? What's the advantage here? So obviously, if you look at a simplified software delivery lifecycle model, we have requirements, usually, but not always, right? We have requirements, we design for those requirements, we build those requirements, we hopefully test them, right? Because we test things, right? We do. And eventually, we deploy to production, we operate those things, and hopefully that's what really we wanted to build, so they deliver a certain value. Many times, requirements are more like a best guess, even when you have a best guess. Sometimes we don't even have that, right? So we not always know what our business counterparts want to build. They don't really know themselves sometimes, right? So we really need to help them and try to understand what it is that they need. So requirements end up being a best guess, because we don't know any better. And it's fine. Sometimes that's what we can do. So obviously, the way to refine those best guesses is to really kind of get some feedback, right? Is this what you wanted? Is it working well? Is it performing according to your expectations? Is it really doing what you wanted it to do? Is it giving you any business value? So we need a feedback loop. And obviously, the best way to actually close the feedback loop is to really provide the means to do so-called experiments, right? So I'm not sure what I want. This is my guess. Let's try to get that out, see how it works, measure it, and then feed that back and kind of close the loop, right? So that we really know whether things work. And if it didn't work, no problem. We just move on and do something else, right? So it's not just about figuring out what we want. It's also being able to do it fast enough. The differentiator for these companies I was talking about before, Etsy, Netflix, Amazon, it's not just that they're well prepared for running these experiments, but also that they can do them fast enough. I mean, if you think about it, if you could run these experiments once a year, right? Or you could run them every 6 months. Or you could run experiments once a month. You could run them 2 weeks a week, and there's a massive difference in the value that these experiments can bring to you if you could do them much more frequently, right? And the value you deliver is directly proportional to how fast you can actually get these experiments to production, right? Okay, so a company like Microsoft, they stated a couple of years ago, about 30% of the changes they implement, they don't deliver any value. They don't deliver what they were expecting to be delivered. Netflix, who is better positioned for the experiments because they have a very high maturity when it comes to experimenting and all these deployments and everything, they said 10%. So still, 1 out of 10 changes they actually build, they didn't deliver the value that they hoped they would deliver. Right? So for example, a company like Microsoft, in Bing, they say they're running 200 concurrent experiments every day. That's a lot, right? In your case, I don't know, how many experiments do you actually need? I don't know, this many. It doesn't really depend on the number. It also depends on, how fast you can really get those experiments implemented, okay? So what's our objective? And of course, the title of the talk gave it away. Our objective should be to do these 50 deployments per day. Why 50? Well, no, I like the number. It's not really, it's not something we have to achieve because probably many of you don't need 50 deployments a day. Maybe you do, maybe not yet, because I believe that even though not all companies need these 50 deployments a day, over time, the demands from consumers, the demands from our business, the demands of our products will push all of us, all our companies, all our industries towards really effective and efficient deployment practices and really get us closer to these 50 deployments a day. So even though I don't think we all need it, we should, design for that. Because obviously, if you design for 50 deployments a day, it means you have solid configuration management, your source code is in really good control, obviously. It means that you have solid automation, solid deployment automation, test automation, release automation. And it means that all these processes, all these infrastructure as code things, which we'll see later, all those are really mature enough to support you doing that. So even though you're not really needing 50 deployments a day, you're ready for it, which is really the idea here, right? And the idea is that in order to achieve that, we need to look at the continuous improvement cycle. And when we have this continuous improvement cycle, we can really, get our experiments, get the feedback, and improve as rapidly as we can. Not just the whole cycle, but also it helps us with the improvement of each one of the steps within our kind of high-level software delivery lifecycle. So requirements, we continuously improve. The designing, build of those things, we continually improve them. QA and testing with continuous improvement and so on with operational, right? So there's a lot of continuous improvement in there. I'm not going to say it one more time. The idea is, let's now get to the bottom of that and see how we can really get there. And unsurprisingly, I'm going to give you my definition of DevOps, or in other words, I'm going to give you the ideas or the pillars behind achieving this continuous delivery, karma or higher level state of enlightenment within DevOps. So the first one would be continuous delivery. We'll cover that in a second. Then this event is called TechArch Day, so obviously I had to put some architecture in there, some of it, because it's very important also from this perspective. Then we'll talk about automation. Automation is essential for achieving any of this, unsurprisingly. And finally, there has to be some culture of it. There's no DevOps without culture, and we'll see that a bit later. So let's start with the continuous delivery. Simplified value stream model. We have an idea, which we hope delivers some value. And whatever happens in between is a so-called value stream, right? Very abstract. We'll leave it there for now. Usually we have many ideas. We hope they deliver many values. We typically wrap them in a big package, and we call that a release. So we take those ideas, requirements, and so on, we build them, and then we take it we deploy, and then as part of a release. Releases grow bigger, which means release timelines grow bigger and bigger. So obviously, there's a risk that that release will not be deployed correctly, that there'll be something wrong with it, and so on. Right? So the size of the release, the amount of ideas we're trying to put together and deploy to production is actually proportional to the failure rate. So the more we try to put in there, the more likely it is we could fail. Right? Okay, so then, of course, what do? We have bigger and bigger and bigger releases, and that even increases our risk for failure even higher. So that's a problem. But we have a bunch of ideas, and we guess well. Remember when I said our requirements maybe just best guesses sometimes? Well, we were lucky, 100% value delivered, perfect. But it took us a long time to get there. We went from nothing to a lot of value, and we were lucky because we guessed well. But our requirements were still best guesses. And unless we're super good, we'd always make some mistakes. The requirements were not really what we wanted, so some of them will not be delivered, some of them will be just not valid. So the value we deliver will not be what we expected. We get wrong. Shit happens. What can we do, right? And again, it took us the same amount of time. It took us forever to really get there in the simplified scale. And we guessed badly, we couldn't deliver the value. I would say that's a problem. Right? So taking a page from the Agile book, because obviously all this continuous delivery and DevOps and Agile, they actually go very well together. The idea is that not only we deliver value incrementally and building on top of the previous value, we do it also at smaller increments, which means that we get to deliver some value incrementally, which helps the business, which then also helps us get the rapid feedback. Right? Because the sooner I can deliver something, the sooner I can get the feedback for it. And I can understand, is this what you wanted? When you measure it with your metrics, you will define KPIs for all these ideas, all these values. When you measure these things according to your KPIs and your metrics, you will quickly see if they work or not, which means I get the feedback, and I can also optimize much faster. I can also really see how things went. Do I need to change any of my processes along the delivery lifecycle, right? So really, this is the idea behind continuous delivery. Being able to constantly deliver value incrementally in a way that we can keep optimizing, keep getting feedback, and the loop keeps going on and on, right? So, but we, being humans, we really like these big releases, so we came up with the concept of, let's do hotfixes. And what we're actually doing is we're just taking waterfall and making it very compressed, and then we think, well, we're doing really continuous delivery. We're continuously getting things. We call them hotfix releases. But that's not really it, because that brings complexity of its own, right? You have parallel development, you have merging, you have to maintain 2 copies of environments, you have to maintain 2 copies of data, synchronize. You've been through that. I'm quite sure I've seen many times. That's actually quite painful, right? So really, what we think of this so-called hotfix releases is just pure overhead. It's an anti-pattern, really. The idea of hotfixes will not get you any closer to continuous delivery. So from this position, based on my opinion, I wouldn't really think that this is the way to go for achieving continuous delivery. All right, so what happens within, we looked at the requirements, delivering value. Let's quickly look at design and build. And the most important concept in there is the idea of continuous integration. You may be familiar with it. Let me give you my definition anyway. It's about taking our components of our system, of our application, of our architecture together. The sooner, the better. And integrate them continuously, see that things work, see that they integrate well, see that they deliver what they're supposed to deliver, see that they fulfill the requirements. And how does good CI look like? Very quickly, as a developer or developers, we think they should be encouraged, not forced, but at least encouraged to push things into version control so that we can have that integration happening. And the more developers you have working on a piece of software, the more important this becomes, right? So get them to really push things to version control much more frequently. Fixing a broken build is always the priority. No longer Friday evening, someone pushes to change things, breaks, I'm done. I don't even see it, I'll come back on Monday. No, the idea is that if the build breaks through, we'll see later some of these tools, you need to fix it. It's your responsibility to get these in place and fix it and make sure it works. Because we'll see later the concept of pipelines, how important that is to that idea. And yes, sorry, Friday evening, you broke the build. I know it's beer o'clock. You have to stay, you have to fix it, right? So these are the concepts, what we think good continuous integration looks like. And it's a really, really essential concept for achieving continuous delivery, because if you don't do any of these, you can't really even think of the next steps. Okay, so testing. The idea of pipelines. Test, and test automatically. The idea is that if you want to really achieve these 50 deployments a day, it's just not possible to have an army of testers testing every change. You have to automate. That's the concept of pipelines. So every change goes through a build, every change goes through the static analysis, make sure our code is secure, make sure our code is not crap, it's actually properly written, follows the specs, and that's not always easy. And then automatic testing. Test fails, everything stops. Test fails again, everything keeps stopped. Now test passes, we can move on with the pipeline, next steps. We have now regression test, and performance test, and security test, and deployment test, and so on and so on. So really get testing automation to a state that you can really do that. And the key there was automation. You can't do this manually. You can't do this just by putting people there. This has to be automated. There's no way around. And we'll come back to automation later because it's a very essential point in all this. And of course, the idea is that if you look at, how faster is it to catch a test at the beginning of the kind of CI phase and at the end. So obviously, pre-commit here means like when you're pushing to something like Git, you can have pre-commit checks already on the developer's workstation. And that test or that change never left my workstation as a developer, so I can get the feedback within seconds, not even minutes, seconds, right? If I get to push it, then it'll take about 10, 15 minutes for those tests to be picked up by, say, a Jenkins builder, right? And then see that it works. Later, when things get integrated, it might take an hour. So obviously, the sooner you can catch that, the better. And even more importantly, if it happens anywhere before the end, the whole thing should stop. Stop the assembly line, right? Again, taking a page from the industrial lean manufacturing book. Failure in the assembly line stops everything, and fix it, get it done. So that's the idea. What about tools? I did mention Jenkins. I did mention a couple of tools, but one thing I wanted to have here very clearly said is that you get all these nice vendors coming to you and say, "We'll sell you DevOps." No, you won't, right? They all have their tools, and they all have their DevOps lifecycle and whatever, HP and CA and Oracle, and they find tools, but the idea is that tools alone will not get you there. It's always about processes, it's always about the patterns, not so much about the tools, right? Even if you want open source or kind of cheap, flexible tools, you go the way of Jira, Confluence, Jenkins. By themselves, they're just tools, but you need to really work on the integration of the tools. You need to actually take your processes and map them on them, or make the tools work the way you want them to work, right? So it's not really about the tools, because the only thing you'll do is you'll spend money for nothing. So tools are there to help you. They're not the solution they're just enablers, but they're not really the solution that you need, right? No matter what the vendors say. So to summarize, continuous delivery principles. Each check-in should be ready for deployment. It doesn't matter that you still have another 100 user stories, and therefore the release cannot be made. It means if I had to release now, it should be ready to release, and it should work. So that's the idea behind that. The same persistent tools across all environments. We'll cover more about automation in a second. It's not about the tools, and a failure at any stage should stop the production line. Let's move on to architecture. And architecture, there's nothing specific about continuous delivery that it couldn't work with SAP and Oracle all stuff. And now they'll come and tell you, as I was saying, Oracle is DevOps, and the new products are perfect, and it's going to work. But it's clear that some of the more modern development practices and more modern architectural practices can help our architectures become better at DevOps. I wouldn't say DevOps-centric, but more like, things like microservices. One of the goals of continuous delivery is being able to deploy things. So obviously, if our application is designed to be a bunch of smaller things working together, that's easier to get there, right? Same thing with fail fast. If I can handle failures in a way that it's all very gracefully handled, and then I can recover from that, it makes my DevOps easier. And that's very hard when you're running one of these big, fat WebLogic stuff or WebSphere. The fine products, I have no bone to pick with IBM or Oracle, but still, they're not really there yet. And ultimately, things like metrics and logs. So again, if my product generate metrics, my product generate logs, my products help me aggregate those things into dashboards, it makes my DevOps and it makes my continuous delivery easier than if they don't. So modern architectures are definitely more conducive to DevOps, right? Although it's not a requirement, it's going to make your life easier. So that's the message I want to give in here. Automation, I promised I would cover these. Release time. I've seen these at many clients where making a release is a process of someone from one team writing a document with the steps, then sending it by mail to someone else, putting a package in a shared folder for deployment, and then someone else picks that up and deploys, and then, oh, I forgot one step, so it's not working. Can you fix it for me? And then you have a team of or a group of people from like 3 different vendors trying to fix things because deployment, it wasn't automated. It was just based on word instructions. We can't do that anymore. That has to go away. And I understand many times things like SLAs and contracts get on the way, but perhaps we should get our contracts with our Accenture, whoever you work with, to say, I want you to make sure you can deploy everything in 15 minutes automatically. Make it very obvious that no matter who does things, they should be automatically integrated, maybe with your CI, maybe with your tooling, but in a way that it's automatic to avoid problems like that, because these are definitely massive disablers of all the stuff we're just talking about. So, and that's what I was saying. So in my unscientific observation of deployment failures, 95% have been due to human errors, human problems. So what's the best way to get rid of these problems? Well, get rid of the humans, right? Eliminate all of them. I see industries fighting with compliance, and they have governance boards and all sorts of stuff to make sure you do things the right way. Well, the best way to do that is by not letting humans be involved. Automate things, test them early enough, right? So that you don't run into all these human errors. It's so easy sometimes that I don't understand why we're not getting there yet. And it's not really because, we're going into the infrastructure. So one of the key concepts that was about deployment automation. There's also about infrastructure automation. The idea of pets and cattle. So basically you have a pet, and if the pet gets sick, you take it to the vet, gets some medicines, you take care of the thing. And when cattle get sick, you just shoot them and get a new one, right? Apply that to infrastructure, right? When your servers get sick, well, kill them, go to your cloud provisioning console, get a new one, deploy, or configure automatically, deploy automatically. You're good to go in typically minutes. And that can be done. But obviously, we need our infrastructure to support those things. And it's not just that there's no shortage of tools for that stuff. The upper layer is all these kind of configuration automation, so Ansible, Puppet, SoulStack, Chef. These tools are there. They're mature enough. This is not a new thing. This is not new at all. These things work. We have some experience. I'm sure some of them are using them. And then bottom layer, once you've gone past the let's configure my server automatically, it's like let's run my servers let's orchestrate across servers and across resources. Like bottom right, that's Amazon's CloudFormation. You can orchestrate anything on Amazon with a nice script. VMs, networking, storage, all the services on top. Docker is actually a great enabler. Stop by the booth later, have a chat with them. Docker is a massive enabler for this stuff, right? Because you can really define your applications as containers. You can define your networks all over software. So it really, really helps you get there. And same thing, the middle one is HashiCorp's Terraform. Really great tool for provisioning infrastructure on OpenStack, on Amazon, or whatever you like. It really, when you reach the point where infrastructure is just a script with a bunch of lines calling a bunch of resources, it's perfect. And you can really then get to the level of infrastructure as code, deployment automation. You need an environment for a quick test. It's a script. The environment is a script, right? So it really helps you get there through the tools. And testing in QA, so obviously we talked about that in the automation section. Automate everything for QA. There's no excuse nowadays. There's later a presentation about security by Yasine, and he was talking to me about integrating security testing into pipelines, because we've seen pretty heavy shit when sometimes looking at code. And the only way to catch that before you even get to production, someone hacks you, is by putting it in your pipelines through test automation, security. So again, very important that we cover test automation when we look at implementing a holistic continuous delivery approach at our companies. So automation, to summarize, eliminate humans. Infrastructure as code is essential, really. There's no way around it. And then test, and then test again as much as you can, and let the machines do it because that's what they were designed for. Finally, culture. I really like this slide. It's a very good example, right? As developers, the stuff gets to production, it doesn't work. Works for me. My machine works in dev. I don't know. Maybe your production development is out of sync. And then you realize that it was indeed some configuration file was wrong, or someone forgot some instructions, or whatever. And typically when you hear other presentations about DevOps, they will always say no silos. I don't want to get there because sometimes it's quite hard to change our internal organizational structures. And there's always, I don't know if you've heard about Conway's law, but it essentially says that the architecture of your software will reflect your organizational structure. And he said, if you have 3 teams working on a compiler, you'll get a 3-phase compiler. And sometimes that gets in the way of DevOps, but there are ways we can go around it, right? Because, in terms of culture, this is from a site called DevOps Topologies, which I really like. They had a lot of kind of patterns for DevOps teams. And I picked a few which I thought could be very interesting. So for example, smooth collaboration. Still dev is dev, ops is ops. They're the separate teams, but they can collaborate kind of usually quite well. That's one of the patterns. Fully embedded, so DevOps as a team, serving both dev and ops. That's also something we're seeing at more advanced clients. Infrastructure as a service, which is kind of a subset of the first one. So basically, dev and ops are somewhat separated, but then ops provides, Amazon console access for the teams to provision, whatever portals for provisioning. So kind of infrastructure as a service where you still give some freedom to the dev teams to configure things, to configure the servers in the way they like. DevOps as a service, which is when you may have a third party doing that for you. So basically, dev is DevOps and ops, and someone is in between kind of trying to work out with both of them and making things work. And ultimately, separate DevOps team, which is probably not the best one, because then it's totally separate. So what I was trying to say here is that there's no right one-size-fits-all when it comes to DevOps culture, right? Still, quality should be everyone's responsibility. There shouldn't be silos to the extent that we can still deliver all the concepts we saw before about CI and CD and so on. So pick the one that works best for you and then try to make it work, because ultimately, again, it's about people and not really about process and not really about the tools. It's just about the people. So pick the one that works. But yes, tools. So again, I think it's a very important topic. I've seen clients buying tools and then it cost a fortune, and then they think that you can replace people with that, and it's not really that. It's always about the processes. It's about the culture. It's very important. We cannot achieve that. We cannot achieve the DevOps nirvana, this continuous delivery nirvana, unless we really have a proper culture, and it's not really, we're not going to get there through tools once again. So, organizational culture, just to summarize, aligned to business priorities, never mind the silos, as long as we all work for the same goal, we're in the right direction. Define your own DevOps culture. Once again, that site was pretty good. Have a look at what they have. I'm sure most of you will see yourselves there in one way or another. It's a pretty good summary of the different cultures of DevOps and kind of topologies for the teams. So define your own, and then make sure it works. Quality is everyone's responsibility, obviously. We give them the tools, we give them all these automation testing and pipelines and everything, but ultimately, it's everyone's responsibility to make sure that we're delivering with quality, and people over processes and tools. This was very abstract so far. It was intended to be abstract, and then I have these, so Accenture, we gave a lot of ideas through this talk so far. Again, all quite abstract. So how does it actually work in practice? So we went ahead and took our very opinionated understanding of how you should build a pipeline, how you should install all these components, how they should run together. And we open sourced it as something that is called the Accenture DevOps platform. This is not meant to be production ready, so you can take that and take it to your company and call it it's my DevOps platform. You can, but that's at your own risk. So don't say I didn't warn you. But the idea is that you take that in there, you deploy it to, it runs on Docker, actually. It's also a good example of what you can achieve with Docker. It runs on Docker, so you can deploy it to your local workstation, you can deploy it to your cloud or Amazon with no complexity whatsoever. And then it gives an idea of, what tools could I use? So there's Jenkins, there's Kibana for log and aggregation, there's a monitoring tool, I can't remember. So it actually pre-installs those for you. It shows you how those things could work together. It has some sample code that you can see in a pipeline. I make a change to my code, and I can see all the way to the pipeline. You can click deploy, and it'll be deployed to a simulated instance. So it's really, I think it's pretty nice as an example of how easy it actually is to take a few of these open source components, put them together, and get them to run to deliver a proper CI practice, at least. So please feel free to have a look. It's there, it's open source, you can contribute, so we're happy to get feedback and bug fixes and so on. So it's available, and actually in our GitHub repo, but you can use a short link. Thank you.
Kiitos. Kiitos, Oskar. Tämä oli mielenkiintoinen puhe. Onko kellään kysyttävää näin heti alkuun vai saanko päästä ensin kysymään omia kysymyksiäni? Hei, tarvitaanko me toinen mikki?
So hi, you were asking about us that are we deploying 50 times a day, so are you doing that?
Nope.
Why is that?
No, because we are many times designing for deploying 50 times a day. We are doing that. But as I said, it's more of something you should design for. It's not necessarily what we all want to do. But when you design for that, if you ever need to scale and get to those 50 times a day, then you can get there much more easily than if you set a lower bar and say, well, I can deploy once a month, that's enough. And then next year business comes and says, we need these products faster every week. And then it's like, well, sorry, I can't do that. So the idea is that you at least design thinking that one day I may actually need to get that far, right? So that's the idea. It's more of a goal that gives you a direction, not so much something you always have to achieve.
Okay, thanks. And one other thing, what has been the hardest part in getting the whole setup done? Is it the culture or some technologies or what?
Culture, yes. At least you're all great clients of us, and you're perfect. But sometimes things like looking at how you do dev and ops, that's very hard. There's been, over many, many years, this big wall between dev and ops everywhere. And it's very hard when you come in and say, can I deploy to production? Let my teams click a button and deploy to production. And then they're like, no. Why? No. Because security. We can help you with that. No. So there's been really these high walls built over time, and then they're not making it easy. And some of these organizations, especially security in some industries, are very heavily entrenched in there, and it's really hard to work with them. So that's been really difficult many times.
Okay, thanks.
Okei, hyvä, kiitos. Oliko muita kysymyksiä? Karoliina tuolla toisella puolella.
Hi, the fully automated test cycle, that was a neat idea, but what in your opinion would be enabler if you have a lot of legacy applications, C-load ones, and you have complex integrations with those? How to go on to build your fully automated DevOps test cycle in that case?
I didn't say it's easy. I didn't say it's easy, and I understand some of the landscapes you're working with are fairly complex. And there are ways, I can't speak about yours specifically, but there are ways we can look into that through automation, through scripting, through perhaps semi-manual procedures sometimes for setting things up. But there are ways we can go around it. It's not impossible, right? I can't give you a very specific answer to that because it really depends on what you're working with.
Yeah, all right, thanks.
Hello.
Hi.
In such a rapid deployment cycles, how would you go about and where are the architecturally significant decisions, the actual architecture made? Is it done per minute?
You mean if it should be...
I mean, where are the architectural decisions that by definitions are hard to change afterwards? When are they being made? In advance somewhere and then you start doing your DevOps or...
So obviously, I mean, what I was saying is that you can retrofit all this stuff into your legacy applications and systems, but it's always easier if when you build an application, you make it DevOps enabled, right? For example, where do you keep your configuration files? Are they inside the application artifact, and then you're forced to do per environment builds, or are they outside of your application artifact, right? So it helps if in the beginning you take all of these things into consideration, because it'll make your life easier down the line. Some of the decisions you need to make early on, it helps a lot. Right? For example, providing metrics. You can retrofit metrics to your WebLogic app, but if you start with that from the beginning and then you think of, I have metrics, I'm going to have to aggregate them and get them and do dashboards, it's easier to get there, right? Did that answer the question?
Yeah, I get the point. When you're starting from scratch, you can do your architectural design, have it designed properly for 50 deployments per day way. But as you go on, you have to make more of the architectural significant decisions. I'm wondering that can you make them, or are you forced to start over when things around you change? And
No, so for example, if you really want to keep deploying 50 times a day, that should be one of your architectural principles. And when your architecture board gets a new request, you should always evaluate that change or request according to your principles. And if that becomes a problem for doing this 50 deployments a day, you need to see that maybe we should change this requirement or this feature and do it in a way that doesn't prevent me from doing those 50 deployments a day, right? So typically you would keep that as a principle always in mind when you evolve your architecture, right?
thank you.
Muita kysymyksiä tähän tuolla vai?
How would you cultivate DevOps as a organizational culture, not just a capability to deploy something frequently?
So you mean how I would grow DevOps, or?
Throughout the organization to the business level, I/O services, everything.
So to a business level, you can't tell them, I'm going to install Jenkins and it's going to make your software faster. You need to go to them and give them a business value, right? So for example, if you're in a product company, you can tell them, I can help you deploy your products 50 times a day, while now you're doing it once a month, right? So that definitely has a value for them. So when talking to business, it's not just about DevOps, it's everything, right? We need to make it more meaningful for them, because at the end of the day, it's just tools that they don't give a shit. It's about really making it meaningful in a way that they get some value out of that. Did that answer your question?
Hyvä. Muita kysymyksiä? Hyvä. Mulle jäi aikaa kysyä mun oma kysymys, joka oli se, että mä en ikinä riko koodia perjantai-iltana, kun mä lähden pois töitä. Mä aina laitan kaikki nätisti just niin, että se toimii. Mutta
It's going to be easier in English.
Sorry, excuse me. So I'm never the one who breaks the code at Friday night when I leave from my desk. But still, we don't have all this DevOps thing happening at my project. So what would be the next person to talk to about how to put it in place? Since I'm doing my job, who should do theirs?
Well, you can talk to me, and then we'll talk to them.
Okay, that's a good idea. We'll talk to you more during the break that we're starting here. Thank you.
Thank you.